Section 10.2, Non-right triangles, Law of Cosines. Our overview, we'll have 3 examples on the law of cosines, and then 1 more example on the area of a triangle. The law of cosines comes with 3 different equations. All these equations are basically the same, just a matter of swapping out either the side or the angle that we're looking for. Given a side A, we can determine what this is by squaring sides B and C, adding them together, then subtracting the product of 2 times B times C, and then the cosine of the angle, which is opposite of this A. Do the same thing with B and C, just a matter of rearranging variables. If, however, we want to look for an angle, we can use this version of the law of cosines. Just a little bit of algebra was done here, but these are the exact same 3 equations from above. Find the unknown sides and angles of the triangle. Much like always, we'll start off by making our chart with alpha, beta, and gamma, A, B, and C. In this case, we're given our beta, that's our 30 degrees. We're given our A, that's our 10. We're given our C, that's our 12. So this is a good reason to use the law of cosines. We do not have one entire row here, here, or here completely filled out. So let's move on to our law of cosines. Our law of cosines states that our b squared will be equal to our a squared, which is a 10 squared, plus our c squared, which is a 12 squared, minus 2 times our a times our c times the cosine of our beta. And, well, with 1 step of algebra, we can just take the square root of both sides, and we can get that our b is equal to 6.0. Now we do have one entire row completely filled out in this table. Now that we have that, we can go ahead and finish this by using the law of sines. We can say that the sine of alpha over 10 is equal to the sine of 30 over 6. Or that our alpha is equal to the arcsine of 10 sine of 30 divided by 6. And what we get here is we get that our alpha is equal to 56.4. Now that we have 2 out of 3 angles, we can go ahead and just do 180 degrees minus 56.4 minus our 30. And that will give us our gamma, which in this case gives us 93.6. Find the angle alpha for the given triangle if side A is equal to 20, B is equal to 25, and C is equal to 18. So making our chart, we have alpha, beta, and gamma. A is equal to 20, B is equal to 25, and C is equal to 18. Once again, we do not have a complete row here, so what we'll have to do is use our law of cosines. We'll use one of the more simplified versions, one where it says that the cosine of alpha is equal to b squared, which is 25 squared, plus c squared, which is 18 squared, minus 2 minus 20 squared, all over 2 times 25 times 18, or that our alpha is equal to the arc cosine of everything we just wrote down earlier. And here we find out that this alpha, what they're actually asking us for, is about 52.4 degrees. Example 3. On many cell phones with GPS, the approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using distances from two known points. Suppose there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart along a straight highway, running east to west. And the cell phone is north of the highway. Based on signal delay, it can be determined that the signal is 5,050 feet from the first tower and 2,420 feet from the second tower. Determine the position of the cell phone north and east of the first tower and determine how far it is from the highway. That says fat, that should say far. So below I have a triangle, have a little chart. So here, all we need to do is find the angles. So let's start off by finding alpha. We'll get that the cosine of alpha is equal to 5050 squared plus 6000 squared minus 2420 squared all over 2 times 5050 times 6000, or that our alpha is equal to the arc cosine of, once again, everything that we had written previously. And here we get that our alpha equal to 23.3. So I guess I should finish filling out this table. Our A was the 2,420, our B was the 5,050, and then our C was our 6,000. Once again, we have a complete row filled out. So here we can go ahead and use our law of sines to solve for one of the other angles. So we can say that the sine of beta all over 5050 is equal to the sine of 23.3 divided by 2420, or that our beta is equal to the arcsine of 5050 sine of 23.3 all over 2,420. And then calculating this, we end up with our beta being equal to about 55.6. Now we have 2 out of 3 angles, so we can find our gamma, 180 degrees, minus 23.3 minus 55.6, and getting an answer of 101.1. Heron's formula is given by the formula that the area is equal to the square root of s times the difference of s minus a times the difference of s minus b times the difference of s minus c, where s is given by a plus b plus c all divided by 2. Find the area of the triangle using Heron's formula. Here we have all three sides, so we should just find our s. Our s is going to be equal to a 10 plus a 7 plus a 15 all over 2, and our s ends up giving us 16. This means that our area is going to be equal to the square root of 16 times 16 minus 10 times 16 minus 15 times 16 minus 7, and then calculating that, we get that the area of this triangle ends up being 29.4 units squared.